Welcome back, class. Today I am going to show you how to factor the sum of two cubes and the difference of two cubes. Let's get started. So in this slide, I have the formula for the sum of two cubes. The sum of two cubes is when you're adding two perfect cubes. So for example, a to the third plus b to the third. When you factor that expression, you'll get a plus b times a squared minus ab plus b squared, which is a formula. One way I like to remember the formula and the signs is by using an acronym called SOP. S stands for same, so same as the problem. So notice how in the problem we have addition. And so in our binomial, the first sign is going to be the same as the problem. So the next sign will be the opposite of the problem. Opposite. And then the last sign will be positive. So once again, when you're remembering the signs, I want you to use the acronym SOP, same, opposite, positive. So let's look at a problem. We have 8x to the third plus 27. When you're factoring the sum of two cubes, the best way to approach it is by expanding each of the terms. So 8 is a perfect cube because 8 is 2 times 2 times 2. X to the third is a perfect cube because it's x times x times x. 27 is a perfect cube because 27 is 3 times 3 times 3. Now we're ready to identify our a and b values. So a will be the cube root of 8. The cube root of 8 is 2. We also need to take the cube root of x to the third. And the cube root of x to the third is x. And because we expanded the problem earlier, we can easily see that a is going to be 2x. Now let's identify b. b is the cube root of 27, and the cube root of 27 is 3. So what I like to do with any sum of two cubes problem is write out the formula. By writing out the formula, I'm able to see where a and b belongs. Okay, so it's a to the third plus b to the third. And then I write out the variables. And the variables are a, b, a squared, ab, b squared. And from there, I fill in the signs using SOP. Same, opposite, positive. Once you have the formula, just plug in your values. So a is 2x plus b is 3. A is 2x squared minus, and then multiply 2x times 3 because that's AB. 2x times 3 is 6x plus b is 3 squared. Let's continue. So that's 2x plus 3 times 2x squared, 2 to the second power is 4, x squared minus 6x plus 3 to the second power is 9. And this is our answer. And I know what you're thinking, Mrs. Orca, can I take the trinomial and factor it? Well, you definitely can try to factor it, but what will happen is that you'll notice that the trinomial in these sum of two cubes problems will not be factorable. So for example, if you multiply 4 times 9, that's going to give you 36, and negative 6 will go at the bottom. If you try to think of two numbers that will multiply to 36 and will add up to negative 6, you won't be able to find any. the factors of 36 are 1 and 36. If you were to add those up, you'll end up with 37. You can also use 4 and 9. 4 times 9 is 36, but when you add 4 and 9, you'll get 13. The same goes with 6 and 6. 6 times 6 is 36, but once you add them, you end up with 12. 12 times 3 is 36, but 12 plus 3 is 15. Because we can't find two factors that will multiply to 36 but will add up to -6, this shows us that this problem is not factorable. And therefore, we would leave our trinomial alone. Now let's look at a difference of two cubes. This is going to be similar to the sum of two cubes. The only difference is that this time we're subtracting. Difference means to subtract. And like last time, we're going to use the same acronym, SOP, which stands for same, opposite, and positive. So the sign is going to be the same as the problem. The variables are going to be exactly the same. So that first sign will be the same as the problem. The second sign will be the opposite of the problem. And the third sign will be positive. Let's go ahead and find the difference of two cubes. In this example, we have 64x to the third minus 1. You want to start off by expanding each term. So 64 is a perfect cube because 4 times 4 times 4 is 64. X to the third is a perfect cube because x times x times x is x to the third. And believe it or not, 1 is a perfect cube because 1 times 1 times 1 is 1. Now we're ready to identify A and B. So the cube root of 64, which we've already seen, is 4. And the cube root of x to the third is x. The cube root of 1 is 1. Now let's write out our formula. We have a to the third minus b to the third is equal to, let's write out the variables and then fill in the signs. A, B, the variables are always going to be the same. The only difference between this formula and the sum of two cubes are the signs. So make sure you use the acronym SOP. AB, A squared, AB, B squared. Now let's fill in the signs. Same as the problem, opposite, positive. Let's fill in our A and B values. A is 4x minus 1 times 4x squared plus, and then we have 4x times 1, which is 4x plus 1 squared. Let's keep going. That's going to give us 4x minus 1 times 4x squared. 4 to the second power is 16, x squared plus 4x plus 1 to the second power is 1. So this is our final answer. And once again, the trinomial is not factorable. So 64x to the third minus 1, when you factor it, you'll get 4x minus 1 times 16x squared plus 4x plus 1. Let's do some more. Let's look at example 2, factor the polynomial. So for this problem, it looks like we're looking at the sum of two cubes because we're adding two perfect cubes. Now let's expand x to the third. X to the third is x times x times x. 64 is 4 times 4 times 4. Let's identify A and B. A is x and B is 4. Now write out the formula. A to the third plus B to the third is equal to, remember to write out the variables, AB, A squared, AB, B squared. Go ahead and use SOP. Same as the problem, opposite, positive. Now the fun part, plugging everything in. A is x plus B is 4 times x squared minus A times B, so 4 times x is 4x plus 4 squared, which is equivalent to x plus 4 times x squared minus 4x plus 4 squared, which is 16. So when you factor x to the third plus 64, you'll get x plus 4 times x squared minus 4x plus 16. And once again, the trinomial is not factorable. Let's do one more. Factor the polynomial 16z to the fifth minus 250z squared. These are not perfect cubes. Let's manipulate this problem so that we do have perfect cubes. Let's start off by factoring out the GCF. 16 and 250 are both divisible by 2. We can also factor out the z squared. 2z squared times 8z to the third is 16z to the fifth. 2z squared times negative 125 is negative 250z squared. Now we have our difference of cubes. Difference of cubes. So I'm going to do a side note because I don't want things to get messy. I want to factor 8z to the third minus 125. So let's start by expanding 8. 8 is 2 times 2 times 2, and z to the third is z times z times z. 125 is 5 times 5 times 5. Now let's identify A and B. A is 2z and B is 5. So let's continue. Let's write out the factors. I have A to the third minus B to the third, which is equivalent to, write out the variables class, AB, A squared, AB, B squared. Now fill in the signs. Same, opposite, positive. Let's plug in those values. A is 2z minus B is 5. A is 2z squared plus 5 times 2z is 10z plus B is 5. Let's continue. It's 2z minus 5 times 2z squared, 2 to the second power is 4, z to the second power is z squared, plus 10z, and 5 squared is 25. So what we did was we factored 8z to the third minus 125. And that's what we got for our factors. Now let's go back to the problem and replace 8z to the third minus 125. So the answer is 2z to the third times 2z minus 5 times 4z squared plus 10z plus 25. And this is our answer. So if you like this video, go ahead and give it a thumbs up and don't forget to subscribe.